Lesson 10-8, Transformers and Electrical Safety. First part is the transformers. Voltage in a wall outlet is approximately 110 volts. Many electrical appliances can't handle that many volts though. Like the computer speakers in the front of my classroom are 9 volts. A projection TV, those are the old, big, ginormous TVs, would take 15,000 volts. A transformer changes the voltage for the appliance. The transformer has 2 coils, a primary and a secondary coil, and then it has this iron core between them. So our AC generator here produces a changing current. It has to be alternating current because we have to change the flux. So the flux is changing in this coil because the current's changing in the coil, thus creating a changing magnetic field. So we have a magnetic field created by this coil, this primary coil right here. And so it's making a magnetic field, and that magnetic field is guided to the secondary coil. So magnetic field goes over here to our secondary coil. Because it was an alternating current on the first coil, the magnetic field is changing. That changing magnetic field in the secondary coil means there's a changing flux in the secondary coil. That changing flux induces a current, an EMF and a current in the secondary coil. The changing magnetic field means the flux in the secondary coil is also changing, and this induces an EMF. But based on the number of loops, it'll be a different size EMF. So our induced EMF is negative number of loops and change in flux over change in time. The primary EMF is that, so it's secondary and primary. If we divide them, we get our volts equal, the ratio of the volts equals the ratio of the number of loops. And so that's our transformer equation. But since the power stays the same in a transformer. So the voltage and the current can change, but the power stays. So we could also do it this way. Notice the volts and the number of loops are lined straight up. So secondary on top, primary on bottom. But the current is upside down because if its power equals IV, that means the current and the volts are inversely proportional. So the S stands for secondary, the P stands for primary. The secondary is the part that goes to the appliance. The primary is the part that's coming from the power source, from the generator or the wall outlet. A transformer that steps up the voltage steps down the current and vice versa. So that means the electrical lines outside have really high voltage. So they used a transformer at a generating station to step up the voltage, so it's high voltage, but it makes it a very low current, and very low current means there's very little heat lost, very little current energy lost to the environment. So to keep electrical lines from getting hot, electrical companies use transformers to step up the voltage up to 11,000 volts. The box on the electrical pole is a transformer that steps the voltage back down to 220 volts. So it comes into your house, and then that is then split so that you have 2 sets of 110 volts. So let's do an example. Let's say an old TV requires 15,000 volts and 0.01 amps to accelerate the electron beam, because what happened is there was this device that sent an electron beam and it hit the screen, and it uses magnets to point where that beam is hitting. And then those electrons hit phosphorescence, which then glow, and that's what you see on the TV. Modern flat screen TVs, of course, are very different. Let's say the outlet in the house supply is 120 volts. The primary coil of the transformer has 110 turns. That means, well, let's use a color we can see. So that is NP. And since this is what's coming out of the house, this would be a primary volts. This is what the TV requires. That would be a secondary volts. And that's what the TV requires. That would be a secondary current. How many turns should the secondary coil have? Okay, so I know both of the volts, so I can use those, and I know one of the coils, so I can use that to find the secondary coil. Again, the primary is what's the power source is, the secondary is what's going to the appliance. So the appliance, the TV, uses the 15,000 volts. The house supplies 120 volts, so that's the primary. We could cross multiply and divide, or just multiply by 100, and you get 1,000 or 12,500 turns on the secondary coil. Very heavy transformer. How much current does the TV draw from the outlet? Alright, so we know the secondary current, the current the TV uses, so that means we're looking for the primary current. Since we know both volts, we'll use volts and current. And remember, this time the current is opposite whatever the volts are. So I have the primary current over secondary current equals secondary volts over primary volts. Fill in the numbers. We're looking for the primary current. We know the secondary current. We know the secondary volts. We know the primary volts, the 120 from the wall outlet. Multiply by the 0.01 amps, or cross multiply and divide, and you get 1.25 amps.